Welcome to the Patton Show. I'm your host, Brandon Patton, and today we're going to be talking about scientific anomalies. The scientific anomaly that we're going to be discussing today is about the planet Venus. First, we're going to talk about the planet Venus. Here, I'll give you a little background information about the planet, which we call Earth's twin. Second, we're going to talk about the anomaly which we know as stationary gravity wave. And finally, we'll talk about Venus's unique spin. So sit back, and I hope you enjoy and learn lots of information about this anomaly. Okay, let's talk about Venus. Venus is the second planet from the Sun and the third brightest object in Earth's sky after the Sun and the Moon. It sometimes is referred to the sister planet of Earth because their size and mass are similar. Venus is also known as the closest planet to the Earth. The surface of Venus is hidden by a layer of sulfuric acid clouds, which we'll talk about later on in the presentation. The planet Venus is named after the Roman goddess of love and beauty and is the second largest terrestrial planet in the solar system. Many scientists believe that billion years ago, the climate of Venus was similar to that of Earth. Venus is also known to rotate in the opposite direction than other planets. Venus is the hottest planet in the solar system with an average surface temperature of 863 degrees Fahrenheit. Even though the temperature is that high, the temperature doesn't vary that much between day and night. The estimated age of Venus's surface is around 300 to 400 million years old. The atmospheric pressure of Venus is 92 times stronger than of Earth's, but Venus is known to have a very weak magnetic field. So now that we have went over a little bit of background information about Venus, we can now move on to the first anomaly, which is the stationary gravity wave. Alright, let's talk about this anomaly, stationary gravity waves. Japanese scientists have detected a large bow anomaly in the upper atmosphere of Venus using their space aircraft, the Akazuki. The structure seems to be about 6,200 miles long and is refusing to budge despite the 225-mile-an-hour winds that surround it. This is an animation of the anomaly shown at a stationary position high altitudes above the feature. The blue and yellow lines represent the evening and morning transition points. Scientists observed this anomaly for a few weeks before noticing that the large bow had disappeared, so this means it's not a permanent feature. As of now, researchers are now waiting anxiously for the possible return of this anomaly. Second, the scientists had to rule out any possibilities such as thermal tide, which are similar to ocean tides, but highly unlikely given that Venus has no moon, or an instrument error on the spacecraft, which they found to not be true. The JAXA researchers concluded that the anomaly is likely caused by a gravity wave, not to be confused with gravitational waves, gravity waves happening where mediums like a fluid or gas fight for a state of equilibrium under the force of gravity. As the waves break into the upper atmosphere, they push back against the fast-moving atmospheric winds with the tremendous force slowing these winds down. That's the theory of how gravity waves typically work. But this newly observed anomaly suggests that they also work on a near planetary scale, affecting the cloud tops for thousands of miles. After discovering this anomaly, researchers began to use computer models to run tests and simulations to see if this anomaly could exist. They came back and found that this anomaly can exist, and as a matter of fact, they are doing more research now to see if the gravitational pull goes all the way up to the 40 miles at the top of the clouds. Looking ahead, scientists plan on comparing the conditions when the bow is present to when the bow is absent. They wanted to collect more data for statistical studies. Now that we have talked about the anomaly of stationary gravity waves, we're going to move on to the final topic of the unnatural spin of Venus. As we have learned by now, Venus is a very unique planet. In fact, it doesn't only have one anomaly, it has two. Venus is known to spin in the opposite direction than most other planets. What this means is the sun rises in the west and sets in the east. Also, their day lasts a little bit more than 243 Earth days. That makes that longer than a Venetian year, which is only about 224 Earth days long. Many scientists believe that the long days are a result of the sun's strong pull on the planet. But still, scientists are still puzzled by Venus retrograde or backwards rotation. Currently, the theory holds that Venus initially spun the same direction as most other planets. In a way, it still does, but it simply flipped on its axis 180 degrees at some point. So basically what that means is it's still spinning the same way, it just flipped upside down somehow. And scientists have tried for many years to figure out what would cause the planet to flip upside down. Other scientists believe that Venus may not have flipped at all. They actually think that instead of it just slowed down its rotation to a standstill and then started going back into a reverse direction. This could fall under the fallacy of untestable predictions because there's no way to test whether or not the spin of Venus is actually stopped and started going the other direction or if Venus flipped over. Continual research will have to be done in order to figure out this anomaly, which could take years and lots of research money. I hope this video was very informal and I hope that you learned a lot about Venus and its two anomalies. These are just two of many anomalies that Venus has. In conclusion, Venus is a very unique planet, and more research needs to be done to see exactly what causes all these different things that we've never experienced on Earth. I hope you've enjoyed this presentation. Thank you for watching.